You are welcome for the next episode in physics. In the previous class, we discussed about what is electric charge. There are two different types of charges. One with a positive charge, it is constituted by protons, and another one is a negative charged particle, and it is called electrons. And also we discussed about what is electric current. What is electric current? The rate of flow of charges. The rate of flow of charges is called, what is actually electric current? Rate of flow of charges, or charge flowing in unit time, and it is called electric current. Now we want to know how electric current flows in a metallic conductor. Consider a metallic conductor like this. We know that is in metals, it's a center part nucleus with a positively charged layer, and around the nucleus there is a number of shells in it, electrons, and the electrons in the outermost shell is called a valence electron. In a metal, these valence electrons are free to move because the force of attraction between the nucleus and that electron is very small. So the electron can move through this conductor. But see, it contains a number of positively charged nucleus, and there is a number of electrons. These electrons, suppose when we consider a metallic conductor or a copper wire, in that copper wire, if it is not connected to an external source, then the electrons does not possess any specified energy. Hence, these electrons in this metallic conductor that moves at a random, and during this random motion they collide with the molecules in it. These electrons, when it is moving at a constant or continuously, when it moves, they collide with molecules in this metallic conductor, and due to that collision, that is, this motion is in zigzag motion. How this one is moving? It is in the zigzag motion. That is the motion we can say as in a zigzag motion. And during this collision, there is a net speed if you take, or the average speed when we take, that one is zero. Average speed of this electron in this metal is zero if it is not connected to an external source. If it is not connected to an external source, the average speed is zero. But when this metallic conductor is connected to an external source, if it is connected to an external source, then the electrons move in as that of in vacuum. That means when this one is moving, when this metallic conductor is connected to an external source, let us a cell, then the electrons in it moves, the electron in it moves as that of what moving in free space or vacuum. But actually the speed of this electron is very small, that means 1 millimeter per second. If even though it can move as in the free space, but there is a large number of atoms, so it motion is or speed of that one is very small, and that speed is called drift speed. That means the drift speed of the electrons in it is 1 millimeter per second. That means drift speed of this electron in the metallic conductor is 1 millimeter per second. 1 millimeter per second is the drift speed of electron in this conductor. So when we switch on, suppose if we switch, here is on switch. When if we switch a bulb in the circuit here, how long it will reach time it will take to reach electron from here to here? It will take a very long time according if the drift speed is very small. Drift speed is very small, but when we switch on, we can see the light is glowing at the same instant. So how that is happening? It is because the speed of current flow in this metallic conductor, the speed of current flow in this metallic conductor is nearly equal to speed of light, that is 3 into 10 raised to 8 meter per second. Then how this happen? Actually, when we switch on, this electron moves from here to this bulb. It will take too long time. But actually there is no physical transfer. That means physical transfer of the electron and electron speed is very small. But when we switch on, what is actually happening? There is a local drift of electrons. Local drift of electrons. That means whenever we switch on, the electrons in it will get energy. So the electron drift from not only from this part, but it take place from every region. It will take place at every region of this conductor. So due to local drift, the speed of current flow is how much? That is nearly equal to the speed of light. That is nearly equal to the speed of light. Now in this way, current flowing in a metallic conductor. Current flowing in a metallic conductor. Now you want to remember 2 points from this. One, how much is the drift speed of electrons? That is 1 millimeter per second or 10 raised to minus 3 meter on second. Then how the bulb glows when we switch on? At the same instant the bulb glows, but there will be no time lag. How this happening? It is due to local drift of electrons. What is actually local drift of electrons? For example, when we switch on, the electron from this part when starts to move with an average drift speed of how much? 1 millimeter per second. At the same instant, the electron in this part also start to move, and the electron here also will start to move. So in this conductor, if you take this conductor, here also electron start at the same instant. The electron here also start, here also start. In this way, the electron throughout the conductor starts to move at the same time. So due to local drift, the current flow at a speed of light. Current flow at the speed of light. How much is the current flow speed? 3 into 10 raised to 8 meter per second. This is the speed of this one. Now, I hope you got idea about how electric current flows through a metallic conductor. You want to remember about what is actually drift speed. It is the speed at which electron physically moving in the metallic conductor. But to blow this bulb, the electron from this part does not move, does not want to move physically from here to here to blow this on. But actually happening when the electron here starts to move, the electron from this region also start at the same instant, because of that light is glowing at the same instant when we switch on. Now, see, we will discuss about some other more terms about this on. What is the potential difference? What is the potential difference? See, suppose we take on metallic conductor. This is a copper wire. This copper wire, now it contains billions of electrons in it. Is the electron in this moving now? Electrons are at a random motion, but the average drift speed when we take how much is it will be? It will be 0. Average drift speed in this will be 0. Okay. Now, if this on this conductor, if we connect it to a cell. Now the cell is the external source. Now the external source is connected to this one. Then what will happen? See, here are two beakers. With this water level same. If we connected a tube in between these two, if the water from A will flow to B, can this water from A can flow to B? No, because here the water level, see here, the water level in these two beakers remains the same. Now, we want flow water from A to B without changing the volume of water in these two. That means volume of water, whatever the volume of the liquid in A, that must be the volume of liquid, and the level remains the same. But without changing the volume of these two, we want flow water from A to B. How is it possible? How? Is it possible? Yes. See here, now this tube, this one is A. This one is B. Now this tube A is, we are going to raise a little above. That means height of this vessel is going to increase a little bit more. Then see, the height of this one become, now without changing volume, we want flow water from the vessel A to B. What way we can do that? See, this beaker A, B, we can rise a little bit. Now, by rising this one, what will happen? The liquid from A to flow from A to, it goes to B. Now, see, the height of the liquid in B becomes more, but the height of these two now same, but from beaker A to beaker B, water is flow. Now, to flow water from A to B, what method we did here? We raise the height of the beaker A. So to flow water, there must be a height difference. What conclusion, what concept we want to get? That is to flow water from one beaker to another, there must be a height difference. There must be a height difference. In the same way, if a metallic wire, as I showed, if I take, there is no, what is electric pressure difference. That means when we consider these two ends, here whatever is the electric pressure, here also the same electric pressure. So there is no electric pressure difference at this condition. And also to the motion of electrons, gravity does not play any role. Gravity does not play any role to the motion of electron in this metallic conductor. So to move electron from this end to this end, what is the method? We want to connect this conductor to a cell this way. When we connected this conductor to this conductor to a cell, that means here the potential is more, here the potential is less. So electron starts to move from higher, that means to the higher potential region from this lower region, because actually the direction of current is this one, but electron flow is this way. Now to flow of current, what we did, here the potential is more, so it flows from here to here, but actually electron flow from this part to here. So to the flow of current, what is required? There must be an electrical pressure difference or electrical energy difference, and that electrical energy difference we used to term as potential difference. What is called potential difference. Now, what is actually potential difference? It is the work done. It is the work done to move a unit charge. That means what is actually potential difference? It is the work done to move a unit charge from one point to another. Suppose the conductor which we took, here the potential difference here is more and here less, means what is it is the work done to move a unit charge from this point to this, and it is termed as a potential difference. So potential difference equal to potential difference is equal to, so potential difference is equal to work by charge. Work by charge. That means it is the work done. See, work done to move unit charge from one point to another. So potential difference equal to work by charge. What is the potential difference? It is the work by charge. Hence, here this potential difference we used to represent with the letter V, and work with the W, charge Q. So V is equal to W by Q. Now we want to find out the unit of potential difference. See, unit of work is we know joule. Unit of work is joule, and unit of charge is coulomb. So potential difference unit is joule per coulomb. Joule per coulomb, and it is termed as volt. And V is the letter used to represent it. That means unit of potential difference is what? Volt. Which is the unit? Volt is the unit. Okay. see, V is equal to W by Q or Joule per Coulomb. Joule per Coulomb is the alt. It is named after the name of Alessandro Volta. Alessandro Volta. That means this unit name is came in the name of what is Alessandro Volta. Now we want define one alt. See, we want define one alt is how much? Suppose 1 coulomb charge flows through a conductor. We know to flow charge through a conductor, there must be no work. So 1 joule work is done. Suppose 1 joule work is done to flow 1 coulomb charge. We know to flow charge there must be a potential difference. Who gives the potential difference? Cell. Here cell is given potential difference. How the cell given potential difference? To provide a potential difference, it does, or it spends a certain amount of energy. That means the chemical energy stored in the cell. Chemical energy stored in the cell, utilized to do the work. So here, due to chemical reaction, this happens. Due to chemical reaction, what happens? The electric current flows from here. So unit of this one is alt, that is equal to, suppose 1 joule work is done to flow 1 coulomb charge, then potential difference we know what is 1 joule by 1 coulomb, that is equal to 1 volt. So how we can define 1 volt? 1 volt is the potential difference when 1 joule work is done to flow 1 coulomb charge. How much work is done? 1 joule work is done to flow 1 coulomb charge, then the potential difference is 1 volt. And the unit of this one is what is the unit of potential difference? Volt is the unit of potential difference, and whose name it came to be known as Alessandro Volta. And voltmeter is the device used to measure potential difference. Which is the instrument? Voltmeter is the device used to measure potential difference. This voltmeter always connected parallel to the device into which we want to measure potential difference. In which instruments potential difference we want to measure, and in its we connect parallel this voltmeter. So voltmeter is used to measure potential difference, and how is it connected? It is connected parallel. We know what is a cell can provide potential difference. How this provide potential difference? Due to the chemical reaction. Due to the chemical reaction. So due to the chemical reaction that will take place throughout whenever the cell is connected to the circuit, even the circuit is open, then also there is potential difference is developed due to the chemical reactions within the cell. Okay, see, now what are the things you want to remember? What is actually potential difference? But it is the work done to move a unit charge from one point to another. And what is the unit of potential difference? Potential difference unit is volt. And which letter? V is the letter used to represent this volt. And the unit volt is came in the name of the scientist Alessandro Volta. How the voltmeter is connected? Voltmeter is used to measure potential difference. Voltmeter is used to measure potential difference. How is it connected? It is always connected. Always is connected. How? Parallel. How? It is always connected parallel to the device. If the potential difference across a bulb we want to measure, then we connect it is parallel across that bulb. This is the method, and the equation to calculate potential difference V is equal to W work by Joule energy. So V potential difference W by J, that is equal to and its unit is we get as volt, and 1 volt, how we define 1 volt is equal to 1 Joule, W by Q, not J, W by Q is used to, that means work by charge. Work by charge is the device here we used 1 volt is equal to 1 Joule per 1 coulomb. 1 Joule per 1 coulomb. These are the things. Now on to questions given in your text related to this one. See, first one, how much work is done in moving a charge of 2 coulomb across 2 points? What is the question? How much work is done in moving a charge of 2 coulomb across 2 points having potential difference of 12 volts? See, here we want to find out how much work. So W is equal to question mark, and charge is given Q, that is equal to 2 coulomb, and the potential difference, that means V is equal to 12 volt. Now work we want to find out. The relation we know, what is V is equal to W by Q. From this relation, W is equal to what? Q into V, or V into Q. Here Q is equal to 2 coulomb and V is 12, so it is equal to 24, that means Joule. This is the work done. Okay, the work done is how much? It is 24 Joule. Now another question here given, need a device that helps to maintain a potential difference across a conductor. Suppose we took a conductor, this is a conductor, and we want to maintain a potential difference across this one. Which is the device used? We can use a cell or battery. By using cell or battery, we can maintain potential difference. Now another question, what is meant by saying that potential difference between 2 points is 1 volt? What is meant by saying that potential difference between 2 points is 1 volt? Potential difference is given as 1 volt. You want to explain what does this mean? See, we know what is actually 1 volt. When 1 Joule work is done, 1 Joule work is done to flow 1 coulomb charge, the potential difference is 1 volt. So it means that in the conductor, to flow a charge of 1 coulomb, 1 Joule work is done. How this definition we give? In the conductor, to flow 1 coulomb charge, 1 Joule work is done. That is the meaning of this question. Now, how much energy is given to each coulomb's charge passing through a 6 volt? See, third question. How much energy is given to each coulomb charge passing through 6 volt battery? How much energy that we want to find out? That means here given potential is 6 volt, and then given how much energy is given to flow each coulomb charge. Each coulomb means charge Q is equal to 1 coulomb. Then how much energy is given. That means work done, that is equal to energy. So we want to find out work done or that is equal to here energy given. Okay. Now our equations we know, the concept which we know, what is V is equal to W by Q. From this relation we want to find out energy W is equal to QV. That is equal to Q into V. Q is 1 coulomb charge, each coulomb means 1 coulomb, and potential is 6 volt, so that is equal to 6 joule. Energy we want to give, work and energy both have the same unit joule. So to move each coulomb charge through the conductor, we want to spend how much? 6 joule energy through that conductor. Okay. Now see the question given once again. How much energy is given to each coulomb of charge passing through a 6 volt battery? See, potential given, each coulomb means 1 coulomb, and energy means work also. So V is equal to W by Q. From this W is equal to, by cross multiplying we get what is QV, and substituting the values we got how much? 6 joule is the work done or energy spent to move that one. Next one is about circuit diagram. To represent a circuit diagram, schematically we use symbols of each component in it. That means to represent a circuit diagram, we use symbols of each component used in the circuit. Some of the common symbols we want to know here are. On is about cell. That means cell is represented with this symbol. That means one longer and shorter. This longer line is positive and this one is negative. Then another one is battery. Battery means it is a combination of more than one cells. See here on cell, and again here positive longer line, and this one is negative. That means when we connect a battery, that means cells are arranged that positive, negative, then this negative connected to positive of another one, and then again negative, positive. In this way we represent what is battery. Then we want to know the symbol of bulb. Symbol of bulb we used to represent this way, or this manner also we used to represent symbol of the bulb. Then now the symbols to represent in a circuit, if we want to represent a cell, we want only draw this symbol, and if it is battery, here 3 cells are represented, and for a bulb this symbol only required to represent in a circuit diagram. For resistor, this is the symbol of what? Resistor. This is the symbol of a resistor. And for symbol of resistor, symbol of resistor is this one. Suppose it is variable resistor. If we use a variable resistor, then its symbol is this way, or this also. This symbol is also used for the rheostat. This is the symbol for rheostat. Rheostat is a variable resistor. So symbol of variable resistors, how we can represent this one or this one. That means when here the length when changes, resistance changing. That is why we use here variable resistor. Then plug key. This one is open. This is closed. That means plug key we can represent it that means it is when it is in open this way, and when it is closed, this is the symbol used for plug key represent in a circuit diagram. Then crossing a wire. Here you see, here this with the contact, a wire crossing we used to represent in this manner. And here we represent a crossing wire without a contact. Here there is no contact. This is the symbol used to represent crossing wire with contact, and this one is without contact. Then we want to represent some other symbols also. This is the symbol for ammeter, and this is the symbol for altimeter. Symbol for ammeter, altimeter. This what is the advantage of using symbol in a circuit diagram? It is easy to represent that device in that circuit. It is easy to represent that device in that circuit. So what are the symbols we discussed on about cell, then battery, then resistor, then variable resistor, then plug key open, plug key closed, then about ammeter, altimeter. Okay. Okay, see, today we discussed about first of all how flow charges in a conductor. There we discussed about what is actually drift speed and its magnitude. How much is its magnitude? On millimeter per second. Then if the electron moves such a small speed, then how the bulb glows when we switch on? It is due to what is a local drift of electron. Actually current flows at a speed, how much? It is nearly equal to the speed of light in vacuum. And how much the value of it? 3 into 10 raised to 8 meter per second. Then we discuss about electric potential. What is the necessary for electric potential? To move electron in a conductor, there must be an energy difference or electrical pressure difference, as in the case of water flows from higher levels to lower level, or wind moves and wind blows from high pressure to low pressure, or heat flows from high temperature to low temperature. Similarly, electrons moves from high potential to a lower potential region. That means in electric potential, we know what is actually electric potential. It is the work done to move a unit charge from one point to another. Then, what is the unit of potential difference? Potential difference unit volt, and which is the equation used there? That means volt, that means potential difference is equal to work by charge. So potential difference is used to represent with the letter V, and work with W, charge with Q. So V is equal to W by Q. Then we define how much is 1 volt. 1 volt. 1 volt is equal to 1 joule per 1 coulomb. This means 1 joule work is done to move a charge of 1 coulomb from one point to another. Then the potential difference between that two points is 1 volt. And then we discuss about which device we used to measure potential difference. Which is the device? Voltmeter. Voltmeter. How is the voltmeter connected in a circuit? Voltmeter is connected. Suppose we want to find out the potential difference across this bulb. Then the voltmeter is connected parallel to this one. Here, voltmeter is connected parallel to this bulb. So, voltmeter is always connected parallel to the circuit. Then we discuss about circuit diagrams. And in a circuit diagram, each component we represent with certain symbols. Which are the symbols we discussed here? First of all, about the cell. Which is the symbol used for it? Which is the symbol used for it? For cell, this is the symbol. Then about the battery. Battery means a combination of more than one cell. So, this is the method to represent a battery. Then key, plug key. This is the symbol when it is open. Then the symbol plug key when it is closed. Then we discuss about wire joints. That means here on wire, and here we are joining another wire. Or here this wire is joining. This is the symbol for wire joined, and another one is wire crossing without joining. Here the wire is crossing without joining. Then resistor. Resistor, the symbol of resistor. Then variable resistor. And also this symbol is used to represent a variable resistor. Then the symbol of what? Ammeter. Then the symbol of voltmeter. Then the symbol of bulb. These are all we discussed today. With this all, we can conclude today's class. Okay.